Alright, here we're going to have the same instructions, so use analytic methods to find extreme values of the function on the interval and where they occur. So the first step is to find the critical points, because we want to know where the function turns around or where it's undefined. So that means we're going to take the derivative and set it equal to 0. That's part of the critical points. The critical points are also where the function is undefined. So we'll have to maybe think about that. So first step, take the derivative and set it equal to 0. So this will be cosine of x plus pi over 4, right? And then set that equal to 0. When is cosine equal to 0? Well, cosine is equal to 0 when, I guess the inside would be x plus 4. Or sorry, pi over 4. Well, cosine equals 0 at, I guess, pi over 2, right? And also at 3 pi over 2. And I'm just taking this inside. Like, okay, well, this has to be pi over 2, because then cosine would be 0. Does that make sense? Sure. All right, cool. So then that would be same thing, plus pi over 4, because that's the inside there. All right, that's when cosine equals 0. It's never undefined, so we don't have any critical points because the derivative is undefined, because it's never undefined. And then what happens next? Well, x, if I subtracted this over, pi over 4, what is that? That's just pi over, well, I'm not going to write that. I'll not show the work. That would just be pi over 4. And then also x equals, what would this be? 6 minus 1 is 5 pi over 4. Okay, so I have two critical points here. One when x equals pi over 4, and one when x equals 5 pi over 4. But I don't know what's happening there. I have no idea. So what I could do is make a sign chart, and that's actually what I am going to do. I'm going to make a sign chart, because I want to know if the function has something like this or like this. And I would know that if the derivative goes from positive to negative, I know I have an absolute, or sorry, not an absolute, not necessarily an absolute, but a relative maximum. If I have the derivative going from a negative to a positive, because that's the slope, then I would have a relative minimum. So that's what I'm going to check here, and I'm going to do that with a sign chart. What is a sign chart? It's just a way that I have to pick values, to test them out, and to see if the derivative changes sign. That's really all it is. And I put my critical points in my sign chart. So this is what I do. Pi over 4. I just list my critical points. And then I make a chart. So those are like lined up. This is lined up. And then I have test points. So I already know that the derivative is 0 there. I want to know if the derivative is positive or negative right before it, and in between, and then right after all of those values. So really, sine of f prime. This is called the first derivative test, because we're just testing it out, seeing if we have a relative minimum or a relative maximum. So, test points. What's smaller than pi over 4? Pi over 6. What's in between pi over 4? I'm going to think of the unit circle. What's in between pi over 4 and, what, 1, 2, 3, 4. What's in between there? Pi over 2 is in between there. Okay, because that's pi over 2. And then what's after 5 pi over 4? Well, what's after this? 3 pi over 2. And now I can plug those into the derivative, because remember, I want to know if the derivative is positive and then change this to negative. I don't really want to know the values of the function. I just want to know the derivative and whether it's positive or negative. So if I plugged in pi over 6 to f prime, lots of people get this confused and they plug it into f. Remember, I want the sign of the derivative. So if I get pi over 6 plus Pi over 4, what is that? Well, you could just do that in your calculator. But I'm going to write it out. So what it was, pi over 6 plus pi over 4. What does that give me? Times, no, 2 times, its common denominator is 12. So 2 plus 3 is 5 pi over 12. That's definitely smaller than 6 pi over 12, and 6 pi over 12 is pi over 2. So really, I have something in here. That means the cosine of it, that value, the cosine of whatever the angle that is going to be positive. And you could actually just plug it in, but I don't want to plug it in. And if I plugged in pi over 2, I would do pi over 2 plus pi over 4. Why are you doing that? Because that's what I'm plugging it into my derivative. So this would be, what, times 2 times 2? That would be 3 pi over 4. Is that true? Is that true? 3 pi over 3. 3 pi over 4. Where is that? This is 1 pi over 4, 2 pi over 4, 3 pi over 4. That means cosine would be negative. Oh, this is pretty easy. And if I plug in 3 pi over 2 plus pi over 4, that would end up over here. That's easy to see that the cosine is definitely going to be positive again. So, alright, now this is what I like to do. The derivative is positive, so that means we're increasing. The regular function is increasing. And then we get a slope of 0. And then the derivative is negative, so then the original function is decreasing. So we have a relative max at x equals pi over 4. And then we're decreasing and then increasing, so we have a relative minimum at x equals 5 pi over 4. Beautiful. So I would write that. So relative maximum at x equals pi over 4, value of, how do I get the value? I just plug in pi over 4 to my original. Be careful with that. What would that be? Pi over 4 plus pi over 4, that would be, what is that? 2 pi over 4, pi over 2. Sine of pi over 2 is 1. So value of 1. And then also, I have a relative minimum, rel min, at x equals, was it 5 pi over 4? 5 pi over 4. And then, yeah, I'll plug that in. Value of 5 pi over 4. Remember, I'm plugging into my original because I want to know the y value. 5 pi over 4, that would be what? 6 pi over 4, that's 3 pi over 2. That's negative 1. Negative 1. Value of negative 1. So those are two things, part of my answers, but I want to check to see if they're at absolute maximum or minimums. If they're the absolute maximums or minimums on this interval, then when I plug in 0 and when I plug in a weird looking, oh no, that's 7 pi over 4. That's 7 pi over 4. When I plug in those, if I get something that's higher than negative, actually, I already know that I can't get something higher than negative 1. Or sorry, higher than 1 and lower than negative 1 because this is sine. I already know that. So these are not only relative maximums or minimums, we would just say absolute maximums or minimums. And I'll plug in the endpoints just to make sure. That's always what you have to do anyway, but I can plug them in my head and I know that they're not going to be crazy. So if I plug in, what? If I plug in 0, f of 0, what is that? F of 0. So these are my endpoints. Endpoints. If I plug in 0, I get sine of pi over 4, that's root 2 over 2. And then f of 7 pi over 4, that's going to be, where's my unit circle? That's going to be that position. So that'll be, what, negative root 2 over 2? Oh, wait, no. Right? Because I got to do 7 pi over 4 plus pi over 4. That's 8 pi over 4, which is 2 pi. So that'll give me 0. So this, what is this approximately? Well, it's definitely smaller than 1. I already know that. So then those are my absolute maximums and minimums, and I know that they're absolute because when I plug in the endpoints, I don't get anything that's bigger than 1 or smaller than negative 1. And these, I would say, I mean, this book, the one that we're using, they would call the endpoints of this relative minimums or relative maximums. And I don't care too much about that. That doesn't really come up too much. So there we go. Wow, that's a long video.